The world of technology never stands still. Companies rise, fall, and innovate. Huawei has just made a major leap developing its own EUV chip machine. Chips are the tiny brains powering our phones, computers, and more. This breakthrough is a huge step for China and the world. For decades, only a few players dominated advanced chip making. Now, Huawei's achievement signals a shift in global tech power. Why does this matter? Advanced chips drive AI, 5G, and supercomputers. Control over chip technology means control over the future. Huawei's success gives China more independence and influence. This challenges the old order and could reshape global competition. In this video, we'll explore what EUV technology is, why it matters, and how Huawei pulled this off. We'll compare it to Western tech and discuss the global impact. The effects will ripple through China and far beyond. Join me as we unpack this pivotal moment in technology. What is EUV technology? EUV stands for Extreme Ultraviolet Light. Imagine light as waves. EUV has extremely short wavelengths. This lets chip makers draw ultra-tiny patterns, smaller than a human hair. EUV is like a super sharp pencil for making chips. More transistors fit on a chip, making it faster and more efficient. But EUV light is hard to create and use. It's absorbed by almost everything, even air. That's why EUV machines operate in a vacuum and are incredibly complex. Creating EUV light requires powerful lasers and precise engineering. Only a handful of companies have mastered this tech. For years, Dutch company ASML was the main supplier. EUV machines became rare, strategic assets. Whoever controls EUV tech holds a major advantage. Huawei's breakthrough in EUV is a game changer for China. It marks a new era in chip making. How are these incredibly advanced chips, the ones powering our smartphones, computers, and even our cars, actually made? It's a question that delves into the fascinating world of microfabrication. The answer lies in a sophisticated process called photolithography. This technique is the cornerstone of modern chip manufacturing. Think of it as using a stencil, a very precise and intricate stencil. This stencil allows us to use light to etch incredibly tiny circuits onto the surface of silicon wafers. It's like creating a miniature roadmap for electrons to flow. The key to creating ever smaller and more powerful chips is the light itself. Specifically, the shorter the light's wavelength, the smaller the features, the transistors, and the connections you can create on the silicon. This allows for greater density and performance. EUV, or extreme ultraviolet lithography, utilizes ultra-short light wavelengths. This allows for the creation of incredibly fine patterns, pushing the boundaries of what's possible. This means packing more and more processing power into each individual chip. It's all about maximizing efficiency and performance. It's like upgrading from a basic printer, one that can only produce blurry images, to a high-resolution laser printer, capable of printing incredibly detailed and intricate designs. But EUV is tricky. The entire process, from start to finish, must happen in a complete vacuum. This is to prevent any unwanted interactions with air molecules. Furthermore, it requires the use of special mirrors called Bragg reflectors. These mirrors are designed to reflect EUV light with incredible precision. These mirrors are not your everyday mirrors. They are made of layers just atoms thick. The precision required is astounding. Because any flaw, no matter how microscopic, can ruin an entire chip. Quality control is paramount. An EUV machine is not just a piece of equipment, it's a massive, incredibly precise system, incorporating powerful lasers, advanced optics, and complex vacuum chambers. It's a marvel of engineering. Even a single speck of dust, invisible to the naked eye, can cause a catastrophic disaster in the manufacturing process. Each EUV machine costs over $150 million, a testament to its complexity and sophistication. And it takes years of dedicated research and development to bring one of these machines to life. That's precisely why EUV technology is the gateway, the key enabler, to the world's most advanced and powerful semiconductors. It's the cutting edge of chip manufacturing. Only a select few companies in the world have truly mastered it, possessing the expertise and resources required. Until now, that is. Huawei's entry into this exclusive and elite club of EUV masters is nothing short of a seismic shift in the global semiconductor landscape. It opens up a whole new realm of possibilities for innovative chip design and advanced manufacturing techniques. The future of technology, the devices we'll use and the innovations we'll see, increasingly depends on breakthroughs in areas like EUV technology. China's dream, a vision deeply embedded in its national identity, is to ascend to a position of global leadership in science and technology. This ambition fuels countless initiatives and shapes the nation's strategic priorities. For years, China served as the world's factory, a manufacturing powerhouse churning out goods for global consumption. However, the crucial core technologies that powered these products often originated from foreign sources, creating a dependency that China sought to overcome. Advanced chips are vital components essential for everything from the smartphones we use daily to the sophisticated systems that underpin national defense. The reliance on foreign-made chips presented a significant risk, impacting the nation economically and posing potential vulnerabilities from a strategic standpoint. Recognizing this, China elevated chip self-sufficiency to a position of paramount importance, making it a top national priority. The government committed to investing billions of dollars in the domestic chip industry. The Made in China 2025 inches plan was launched with the explicit aim of fostering a robust and competitive domestic chip industry, capable of meeting the nation's needs. However, the path to manufacturing advanced chips is fraught with challenges, demanding specialized expertise, substantial financial investment, and perhaps most critically, time. Western companies held a dominant position, controlling the essential tools and technologies required for chip manufacturing, particularly the highly advanced EUV lithography machines. Escalating trade tensions and increasingly stringent restrictions further complicated China's efforts to gain access to these critical technologies. Huawei found itself at the very epicenter of this technological storm, facing a severe crisis when it was cut off from the supply of foreign-made chips. This external pressure served as a catalyst, fueling an unprecedented national drive towards technological self-reliance and innovation. Huawei's recent breakthrough with EUV technology stands as a testament to this unwavering focus and determination. It represents a significant turning point, signaling a new chapter in China's ongoing quest for complete technological independence. The journey has been a long and arduous one, marked by numerous obstacles and setbacks, but the long-term impact of this achievement is poised to be both profound and lasting, reshaping the global technology landscape. Huawei's path to EUV technology is a story of resilience. When sanctions hit, many thought Huawei's ambitions were over. Instead, the company doubled down on research and innovation. Developing EUV from scratch is a monumental challenge. ASML took decades. Huawei had to master extreme physics and engineering, often in isolation. Despite setbacks, they persisted, collaborating with Chinese partners and universities. Details are secret, but patents and reports show real breakthroughs. This was a national effort to solve a national challenge. Huawei's success proves that technological leadership can shift. It's not just about building a machine, it's about building a foundation for future innovation. This achievement will inspire China's next generation of innovators. For years, ASML was the only name in EUV machines. Their tech is the gold standard, massive, precise, and proven. Companies like TSMC and Intel rely on ASML for cutting-edge chips. Now, Huawei has entered the EUV arena. How does it compare? Details are scarce, but Huawei's first machines may lag behind ASML's latest. Still, crossing the EUV threshold is a huge achievement. Even if a generation behind, Huawei's machine breaks the monopoly. It gives China a strategic capability and a path to catch up. The real story is potential. With investment and talent, Huawei can close the gap. China's vast pool of engineers and strong government support will accelerate progress. The West won't stand still, but the race is now open. EUV leadership is no longer a one-horse race. Competition will drive innovation on both sides. The global chip landscape just got a lot more interesting. Huawei's EUV breakthrough is a game-changer for China's tech industry. For years, Chinese chipmakers depended on foreign equipment, especially EUV. Now, with a domestic option, Chinese companies like SMIC can advance faster. This will boost China's electronics sector and fuel innovation in AI servers and smart cities. Self-reliance means less vulnerability to external pressures. Chinese tech firms gain freedom to innovate and compete globally. The impact on talent is huge. More scientists and engineers will be drawn to chip research. Universities and institutes will ramp up their focus on semiconductors. This creates a cycle of innovation and skill building. A domestic EUV supply chain will grow, benefiting optics, lasers, and materials industries. China's semiconductor ecosystem will become more robust and self-sufficient. The ripple effects will strengthen the entire tech sector. Economic and strategic benefits will be far-reaching. China is building not just machines, but a foundation for future growth. Huawei's EUV machine is making waves worldwide. Global tech leaders are watching closely. This challenges the old balance. The semiconductor industry is strategic, affecting economies and security. A new EUV player changes the game, prompting policy shifts and new strategies. For chip buyers, more suppliers mean more options and potentially lower prices. But it could also spark new geopolitical tensions and debates over fair competition. ASML's monopoly is broken. Huawei's entry will spur faster innovation. The entire supply chain will adapt, exploring new partnerships and strategies. International collaborations and rivalries may shift. Some countries may seek to partner with China, others may strengthen alliances to compete. The global tech landscape could become more fragmented. Tech decoupling is already underway. Huawei's success could accelerate it. The world must navigate these changes carefully. The chip race is now truly global. Huawei's EUV breakthrough. This achievement represents a significant leap forward in semiconductor technology, is a landmark event in tech history. It signifies a pivotal moment, potentially reshaping the landscape of the global technology industry and heralding a new era of competition and innovation. It's more than a technical feat. It signals a shift in global power. This breakthrough has far-reaching implications, extending beyond mere technological advancement to influence international relations and economic strategies. For decades, advanced chip tech was controlled by a few, creating dependencies. This concentration of power has shaped global supply chains and influenced the geopolitical landscape. Huawei's success challenges this order and shows China's growing innovation. It underscores the nation's commitment to technological advancement and its increasing capabilities in critical sectors. The race for tech supremacy is heating up, making self-reliance crucial. Countries are now recognizing the importance of developing their own technological capabilities to ensure economic stability and national security. Huawei's journey proves that barriers can be broken with determination. Overcoming significant obstacles, they've demonstrated the power of focused research and strategic investment. This will inspire other nations to pursue their own tech independence. We can expect to see increased investment in domestic research and development programs worldwide. A more multipolar tech world could drive faster progress. With more players contributing to the innovation ecosystem, the pace of technological advancement is likely to accelerate. The path ahead will have competition and friction. Standards, IP, and market access will be debated. These discussions will be crucial in shaping the future of the global tech landscape. The world must balance cooperation and competition for the greater good. International collaboration and knowledge sharing will be essential to address global challenges. Technological progress should benefit all, not just a few. Ensuring equitable access to technology is paramount for fostering inclusive growth and development. Huawei's story is a reminder. Human ingenuity thrives under challenge. Innovation often arises from necessity and the drive to overcome limitations. As China invests in tech, the world will watch and adapt. Nations will need to adjust their strategies and policies to remain competitive in this evolving landscape. The future of technology is more dynamic, and the game has changed. The rules are being rewritten, and a new era of technological competition and collaboration is upon us.